Here is a fully functional Linux operating system, running securely inside a window on your current desktop computer. This diagram outlines the 3 specific prerequisites you need to build this setup: 30 gigabytes of free disk space, a host machine with at least 8 gigabytes of RAM, and a downloaded Ubuntu ISO file. By building a virtual machine, you create a strictly isolated sandbox. This ensures you can learn, experiment, and make mistakes with zero risk of overwriting or damaging your primary hard drive. Step 1 is to open your hypervisor program and point it to the downloaded Ubuntu ISO file to create a new virtual machine. Next, the software will ask for your basic credentials to streamline the setup. You will need to enter a full name, a username, and a password. Keep a careful record of the password you choose now. You will need it to log in, but you will also need to enter it every time the system requires administrative or root-level permissions. Give your new virtual machine a recognizable name and select a directory folder on a hard drive that has plenty of free space to house the installation. This mockup shows 2 critical storage settings: setting maximum disk size to exactly 30 gigabytes and selecting the Store as Single File option. This creates one clean, unified data block, rather than scattering a messy cluster of smaller files across your host system. Defining these storage boundaries accurately at the start ensures your host machine's hard drive stays organized and prevents disk management errors down the road. Before you click the final Finish button, stop. The default settings will leave your new Linux environment severely underpowered. Instead, navigate to the menu and click the Customize Hardware button. This sliding scale graphic demonstrates the first necessary adjustment, moving the memory allocation up from the restrictive 1 GB default and into the 4 GB or 4096 MB range. Next, go to the processor settings and increase the core count. Allocating multiple CPU cores allows the virtual machine to actively draw on your host computer's actual processing power. Adjusting these hardware allocations ensures the Linux sandbox remains responsive, avoiding the sluggish performance often associated with default virtual machine settings. With the hardware defined, complete the wizard. The system will boot, and the modern Ubuntu installer takes over to handle the complex configurations completely on its own. This progress bar visualizes the out-of-sight technical phases: formatting the disk partition, copying core files, and configuring the grub bootloader. Finally, a specialized integration block locks into place, installing open VM tools so your hypervisor and guest Linux system communicate seamlessly. This entire sequence is completely hands-off. Depending on the speed of your computer's hardware, it will take roughly 5 to 10 minutes to complete. This hands-off approach ensures the core configuration remains consistent, providing a reliable foundation for the system before you begin your own customizations. Once the installation finishes, the system will automatically reboot and arrive at the standard graphical greeter screen. Click on your username and type in the exact password you established during the initial setup phase. You will land on a clean, newly loaded desktop. Right-click anywhere on the background and select Open in Terminal to bring up the command line. This stylized layout highlights the diagnostic command we need. Type df, followed by a -t for the file system type, and a -h to format the output into human-readable gigabytes. Then press Enter. Look at the resulting terminal output and locate the main ext4 file system. In that row, confirm that the total disk space matches the 30 gigabytes you allocated during the build. Verifying the internal storage math directly through the terminal proves your sandbox is successfully built and safely contained. You are now cleared to begin your risk-free exploration of Linux.